Welcome to this explainer. Today, we're diving into a truly fascinating, purely speculative theoretical paper by Dr. Ahmad Rihan. It's this incredibly ambitious framework that basically attempts to draw a direct line between the microscopic quantum decay happening deep inside stars and the macroscopic expansion of the entire universe. I mean, it is a mind-bending journey of scale, and we're going to break it all down together. Okay, let's dive into this. For decades, one of the absolute biggest mysteries in astrophysics has been what exactly is pushing the universe apart, right? We usually just throw our hands up and blame mysterious dark energy. But what if there was a mechanical explanation? Well, Dr. Rihan's paper offers a completely new theoretical framework that attempts to answer this massive cosmic question without relying on an unseen dark energy cosmological constant. And that brings us to the core definition of today's explainer, the hybrid Core-Cascade hypothesis. Basically, it's a speculative model proposing that the decay of unstable heavy nuclei deep inside stars actually inflates nested electromagnetic bubbles, and it's the physical growth of these bubbles that drives cosmic expansion. So today, we are taking a micro to macro journey. We're starting from the absolute tiniest particles and zooming all the way out to the largest cosmic webs in existence. Here's our roadmap for the journey. 1. Inside the stellar core. 2. Nested electromagnetic bubbles. 3. Expanding the cosmos. 4. Forging the cosmic web. And 5. A speculative overlay. Starting right off with part 1, inside the stellar core, the microphysics of energy generation. Now, what's really interesting about this slide is the sheer contrast between established science and this new hypothesis. The standard solar model states that stellar core fusion is driven entirely by things like the proton-proton chain and CNO cycle. Dr. Rihan's hybrid model, it doesn't replace this. It actually keeps it. But it suggests there's a tiny subdominant parallel channel operating right alongside it, and this one is driven by the decay of unstable heavy nuclei. You can actually think of this heavy nucleus cascade as a sort of hidden thermostat inside the star. According to the math in the paper, this secondary channel functions as a regulatory depressant. So if the core temperature rises too much, this cascade mechanism effectively cools things back down by expanding the core slightly, which prevents the star from overheating. It's a really brilliant theoretical move, honestly, because it safely keeps the internal thermodynamics of the star absolutely identical to what we observe in reality. Moving to part 2, nested electromagnetic bubbles. We're scaling up to the macro now. Picture a set of Russian nesting dolls. This is exactly how the hypothesis envisions the architecture of space. Step 1. Individual stars emit energy that inflates local planetary electromagnetic cavities. Step 2. The combined energy of all those stars inflates a massive bubble around the entire galaxy. And step 3. The cumulative energy of all those galaxies inflates massive supercluster bubbles. Energy is just constantly being passed upward, from that tiny stellar core all the way out to these massive cosmic cavities. As the author writes, each star is surrounded by a quasi-spherical electromagnetic cavity. The nested bubble dynamics are therefore a formal electromagnetic overlay. I really want to emphasize that word, overlay. This theoretical framework is placed right on top of standard astrophysics. It doesn't break the rules of the interior stellar structures we already know and love. It just adds a new invisible layer of mechanics to them. Part 3, expanding the cosmos. Time to rethink the Hubble flow. So according to this hypothesis, the expansion of the universe isn't just space itself magically stretching, a concept astronomers call metric expansion. Instead, the universe is being physically pushed apart by the cumulative hierarchical growth of these nested electromagnetic cavities. And what's powering this continuous growth? The unending energy output from those tiny, microscopic stellar cores we just talked about. So the crucial point is how this neatly bypasses the complicated physics we normally use. Usually, when we look at distant galaxies, their light is stretched out. It's shifted to the red end of the spectrum. Standard model says space dynamically stretches the light. But in this bubble model, as a photon travels across the universe, it crosses billions of these expanding bubble walls, losing just a tiny fraction of energy each time. And that physically causes the redshift. Plus, the inward flow of energy from even larger, unseen cosmic bubbles acts as the mechanism for the universe's accelerating expansion. This completely removes the need for a mysterious dark energy cosmological constant. I mean, talk about a massive claim, right? On to part 4, forging the cosmic web, voids and filaments. Let's move to and see how this builds the universe step by step. First up, energy from stellar sources physically inflates the bubble. Second, as this bubble wall expands outward, its electromagnetic stress acts like a giant broom, literally sweeping mass along with it. Third, the area left behind is completely evacuated, becoming a massive, empty cosmic void. And fourth, where these expanding bubbles inevitably bump into each other, their walls intersect, compressing all that swept-up plasma into bright, dense ridges known as the filamentary web.
When you actually run this simulation, the results are pretty striking. Roughly 90% of the mass is swept out to the walls and filaments, leaving only 10% behind in the void interior. This theoretical mechanism perfectly explains why modern telescopes see exactly this: massive, dark, empty voids in space, surrounded by incredibly bright, dense star-forming filaments.
To really prove this out, the paper simulates this over a massive cosmic timeline. At 4 billion years, an initial void state sits at a radius of 15 megaparsecs. By 8.9 billion years, continuous energy has grown that radius, evacuating more mass. And by today, at 13.8 billion years, that same void has expanded to nearly 25 megaparsecs. It takes incredibly complex mathematical Lorentz forces and translates them into a simple, elegant story of a sweeping, expanding bubble growing over billions of years.
And this brilliantly illustrates how neatly the theory accounts for the dual nature of our universe's geography. Voids are simply the evacuated bubble interiors, dark and underdense. Filaments are the intersections where bubble walls crash into each other, overdense and highly conductive. Basically, the entire topology of our universe is just a massive foam of intersecting electromagnetic bubbles.
Bringing us to Part 5, a speculative overlay. Let's look at its compatibility with established science. Dr. Rehan goes to great lengths to validate that this model doesn't just destroy standard astrophysics. It perfectly matches our sun's radius and brightness. It preserves the exact neutrino fluxes we detect in underground labs like Borexino and Super K. It stays well below helioseismic inversion uncertainties, which basically means it doesn't disrupt sound waves traveling through the sun. On a cosmic scale, it perfectly recovers the temperature of the cosmic microwave background radiation, and it maintains our standard mathematical calculations for kinematic redshift relations. In short, it operates completely safely within the error bars of mainstream astrophysics. But, there is a catch, and it literally all comes down to a single number: 0. For this theory to perfectly match standard astrophysics without breaking it, the efficiency limit of that microscopic Core-Cascade, the decay of those heavy nuclei we talked about, must approach 0. It has to be vanishingly small. If it were even slightly larger, our current models of the sun would totally break. Because the required energy is so incredibly tiny, this framework currently remains purely hypothetical. As the author objectively notes, the account is a formal speculative overlay. It does not supersede the standard FLRW plus lambda CDM description. So Dr. Rehan isn't trying to tear down the standard cosmological models we rely on. Instead, he's just offering a complementary physical mechanism, a way to potentially explain the why behind cosmic expansion through physical forces, rather than just relying on the math of stretching space. Which leaves us with a profound sense of scale. If a microscopic, near-zero level of stellar decay can silently inflate nested bubbles that sculpt the macroscopic cosmic web over billions of years, what other tiny mysteries are hiding deep inside the stars just waiting to be discovered? Thank you for exploring this absolutely fascinating speculative framework with me today. Keep looking up and keep asking questions.